All right. So, hello and welcome everyone. We are live again. So, welcome back to this amazing platform of Tutee Learning. And today, our goal is to discuss about the other miscellaneous concepts of parabola, right? So, welcome back to this lecture number 7 on parabola. And with this particular lecture, we'll be trying to finish the entire discussion of the chapter of parabola, right? And however, there are certain questions that we need to discuss about, and what I'm thinking is that we'll discuss those questions in our some of the upcoming lectures. Okay, so for the time being, let's discuss about the miscellaneous concepts or properties regarding the parabolas, and with that we'll be trying to end this chapter today itself, right? And in the next class we are going to start with our new chapter, that is going to be ellipse. Okay, so I hope you are all excited to finish this particular chapter of parabola. So far we have been discussing a lot of things, especially in coordinate geometry. So by now you must have already got the feeling of how a chapter in coordinate geometry is like, right? Or how do we actually study any part of a coordinate geometry, right? So with that particular thing, let's get started on the miscellaneous concepts, and today we'll discuss about certain more concepts that you have already seen in case of a circles, like chord of contact or pair of tangents, right? So those all concepts we will try to discuss in today's lecture, and with that we'll try to end this particular chapter, right? So with this particular thing, let's get started. So, and if you are new to this particular platform, I would request you to please subscribe and also hit the bell icon, so that whenever we are live on this platform, you basically get a direct notification and you can join us live from this channel. Okay, so in this platform we are basically helping students to prepare for their upcoming JEE mains and advanced examination. Okay, so with this, let us get started. Okay, so as I was discussing about another very important property regarding parabola in the last class, if you have watched the lecture number 6 of parabola, you must have gone through this particular discussion, right? That is the use case of parabola as a perfect reflector, or the case of a parabolic mirror, right? So today we'll try to discuss about that what is that particular property that makes parabola a perfect reflector. Right. So today we are going to discuss about the reflection property of parabola. So let us first of all discuss about let us discuss about the reflection property of a parabola. Okay. So let us discuss about the reflection property of a parabola. Okay. So let us discuss about this particular thing in detail, right? Or what is the use case of a parabola, or using it as a perfect mirror, right? So let me take the case of a standard parabola. So if I take the case of a standard parabola like y square equals 4ac, which is my standard parabola, and also let me try to draw that over here, right? So if I try to draw that in my x and y coordinate, the parabola would look something like this, right? Okay. Now let us say that if I take up any point on this parabola, let us call that point as P point. So if I take up any point on this parabola, and let us take the parabolic point that is basically in terms of the parameter, which is basically t. So we can say or write down the coordinate of this point as at square comma 2at, right? Now let us say that I try to draw a tangent to this point P such that it meets the axis of the parabola at some point. So let us try to draw a tangent to this point P of this parabola such that this tangent at point P meets the axis of the parabola at point T. Okay, so this is the point where the tangent to point A meets the axis at T, right? And let us also call the vertex of the parabola at V. Okay, now if I have this discussion, and if I try to write down the equation of tangent at point P, so the equation of tangent at point P will be simply given in terms of parametric form. So by now we have already discussed about this, that is going to be Ty is equals to x plus at square. So this is the parametric equation, or in the parametric form, the equation of tangent at any point P, right? Now if I try to get or resolve the coordinate of point T, because the x-axis is the axis of the parabola, so in order to get to the point T, therefore it is going to have the y coordinate to be 0. That means that t coordinate would come out to be minus of 80 square comma 0. Minus of 80 square comma 0 would be the coordinate point of this point of at parabola. The tangent at the point P of the parabola intersects the axis. Okay, so this point T is going to be minus 80 square comma 0. Okay, so this is the coordinate on the tangent where this tangent intersect the axis, right? Now why I am doing all this sort of things, you will try to understand. And in the similar manner, what I'm trying to also do is that if I draw a normal to this point P, something like this, so we have already discussed that the normal through any point of the parabola except the axis always do not pass through the focus of the parabola, right? So this is how the normal to the point P is going to look like, right? Now if I say that, or if I try to make sure, or what I am basically trying to showcase through this particular property is that the tangent at any point P to the parabola bisects the angle between the focal chord through P and the perpendicular from the directrix. So from, if I take up, this is my directrix, so directrix is going to have the coordinate as x equals to minus of a, right? So let us say this is my directrix. So let us say this is my directrix, which is having the coordinate x equals to minus of a. Okay, so from this directrix, if I drop a perpendicular from point P on this directrix, this is going to be some perpendicular, and let us say this particular point is M, right? And if I draw a chord or focal chord, like PS is a focal chord, so what I'm trying to say is that the tangent, this particular tangent at this point P actually bisects this particular angle, right? Okay, so might be the figure looks very odd, but it says that this particular angle, that the angle, what I'm trying to convey over here is that the angle SPT is equals to angle MPT. So this is a very important conclusion that will come out because of this expression. Okay, so let me try to show you that how does this expression comes out in reality, right? So from this result, and if I also want to know that what is the ST distance, so over here, if I try to find out the distance ST, which is basically equals to SV plus VT, right? And if I compute this particular relation, it is going to come out as A plus AT square. A plus AT square. Okay, A plus AT square is the value of this line ST. Okay, so this is going to come out as A times of 1 plus T square. In a similar manner, if I want to calculate what is my SP, and SP we already know that because the eccentricity of a parabola is equals to 1, so SP is equals to PM, and that is equal to A plus AT square, which is equals to A times of 1 plus T square. So from here I can see and prove that ST is equals to SP. So I can easily prove this particular relation, that is SP is equals to ST, right? So this particular distance and this particular distance is similar, right? That means in triangle PST, this is an isosceles triangle, therefore this angle and this angle would be equal, right? So therefore in this triangle, in this isosceles triangle, from here I can make another conclusion that, so from this isosceles triangle property I can make another conclusion that your angle STP is equals to angle SPT, right? So since these are alternate angles, right? And I can also say STP is equals to angle MPT. Why? Because, so if you look carefully, STP is equals to MPT, right? Because since these lines are parallel lines, since the axis and this perpendicular line from the directrix, they are parallel, so these are alternate angles. So I can write over here that STP is equal to MPT, that because they are alternate angles, right? Just because they are alternate angles, so this is going to hold true, and therefore from here I can easily say that SPT is equals to MPT. So SPT is equals to MPT, right? So therefore the tangent at any point P actually bisects the angle between the focal chord and the perpendicular from point P to the directrix. Okay, so therefore if I take the direction of this line, that means that if I take this direction of the line from PM as like this, that means that this line, so if I say that I have a torch light and I give the ray of light along this particular direction, then hitting at point P, it is going to reflect and come along this point S. So, okay, so line from this direction is going to hit at point P and is going to pass through point S. That means from a light source from infinity is going to pass through the focus. On the similar manner, if I have a light source at a focus, and if I plot light over here, then the light source from focus would again reflect and go towards infinity, right? So this is the condition that we use the case of this geometry of this parabola to utilize it as a perfect mirror. Okay, I hope this condition is clear to all of you. Is this discussion clear? Do let me know in the live chat, is this clear or not? Okay, so this is a very important and a crucial property of parabola, that we try to use it for our case of geometrical applications. Okay, so this is one of the very crucial application of parabola. We'll try to use that up in our real life applications. Okay, is this clear to all of you? Is this part clear? Okay, so this is a very important property of parabola, and we'll try to see some of the problems regarding this, right? Is this clear? Okay, so let us take up some problems to understand. Okay, so let me take some good problems. Okay, so this is one of a very crucial and important problem that you can try to solve. So the problem looks, I am giving the problem over here. All right, so the problem is on the screen. I think you all can try to solve this problem. Okay, this is a subjective problem where you have to prove that the slope of the tangent at the co-normal points are given in geometric progression. Okay, so we have already discussed about what is the co-normal points, right? So please try to solve this problem, and then we can definitely go on discussing about the solution of this problem. Okay, so give a try. Okay, and do let me know whether are you able to prove this or not. Okay, if you are having any conceptual doubt, do let me know, and we can always definitely work over it, right? Is this part clear to all of you? Is this discussion clear? Okay, so try to solve this problem. So try to solve this problem and let me know what is the answer you're getting, or whether you're able to prove this result or not. Okay, so take your time and do let me know. Okay, so all right, so let us try to see about the discussion of this problem. Okay, so if I try to talk about the problem what is given to us, it is given that for a given parabola, which is basically of the form that is y square is equal to 4x, which is a very standard parabola, right? And if I try to draw the equation of normal, if I try to draw or write down the equation of the normal, if I try to draw the equation or write down the equation of normal at any point P, which is given in terms of parameter. So over here the parameter is going to be, so the any point P can be given as t square comma 2t, right? Because the value of a is equals to 1. So the equation of normal will be of the form 2x, minus tx plus 2t plus t cube, right? This is how the equation of normal would look like. Okay, now it is said that if the normals from any point to the parabola cuts the um, line x equals to 2 in a point whose ordinates are given in AP, right? So what do I mean by that? That means that if I cut the normal by the line x equals to 2, then the values we will obtain for y. So if x equals to 2, then the values of y that would come out is, so x equal to 2, it would be definitely is equals to t cube, y equals to t cube, right? So if these points are there, since these are 3 points, so let us call it t1 cube, t2 cube and t3 cube, okay? And it is given that these y coordinates are given in AP, right? Okay, so from here, since these are in AP, what I can also write that 2 times of t2 cube is equals to t1 cube plus t3 cube, okay? So t1 cube plus t3 cube would be equal to 2 times t2 cube, right? Now if I simplify this expression with the algebraic relation, so I can write this as t1 plus t3 whole cube minus of 3 t1 t3 times t1 plus t3, okay? So from here, one relation I will also get is that, so t1 plus t2 plus t3 is equal to 0, right? And from here I can substitute, that is t1 plus t3 would be equals to minus of t2. So from over here, if I substitute over here, what I'm going to get is that is a very well known established condition for case of a parabola, right? We have already discussed about it, right? So from here I will get 2 times of t2 cube would be equals to minus of t2 cube minus 3 times of t1 t2 minus of t2, right? This is how the expression would look like, and if I simplify this expression, I'm going to get 3 times of t2 cube would be equals to 3 times of t1 t2 and t3. From here, another very important relation I will get is that I will get t2 square is equals to t1 t2, right? T2 square is equal to t1 t2. That basically means that my t1 t2 and t3 are in GP, right? T1 t2 t3 are in GP. And if you recall, the slope of the tangent at any points at point P whose parameter is t, the slope of the tangent is basically given as 1 upon t, right? So if t1 t2 t3 are in GP, so the inverse of them is also in GP, right? So 1 upon t1, 1 upon t2, 1 upon t3 are also in GP, right? So this is a very interesting problem that you can always try to think over here, right? Therefore, in this manner, you can easily prove that if I draw the slope of the tangent at the corner points, they are always going to be in GP. Is this clear to all of you? Okay, so this is how we prove these kinds of problems. Okay, is this clear? Is this part clear to all of you? Okay, so do let me know if you have any issues or confusion in the problem, and then we can proceed further, right? All right. So with this part, let us proceed towards the other miscellaneous part, and the first miscellaneous part that we're going to discuss is very simple. That is going to be the chord of contact, right? So we have already discussed about chord of contact, chord of contact, right? So we have already discussed about chord of contact. Okay, so chord of contact is basically that. So if to a parabola, let us take the case of a standard parabola. So if to this standard parabola whose equation is given as y square is equals to 4ax. Okay, so for this standard parabola, y square is equal to 4ax. Okay, so if I take up any point outside the parabola whose coordinate is h comma k, and from this point P, if I draw two normals, two tangents to this parabola, let us say the tangents are drawn at point R and point Q. Okay, and whose coordinate are x1 y1 and x2 y2. Okay, so let us say these are the points, right? So if I draw this chord between point Q and R, this is also called as the chord of contact, right? So this is called as the chord of contact. We have already seen it, right? In our chapter of circle, we have seen that this equation can be given as t is equals to 0, right? Which is very simple, right? But we will try to understand again whether it is holding true for the case of parabola or not. Okay, so if I try to write down the equation of PQ line, okay, so the tangent PQ, if I try to write down the equation, the tangent PQ, that is going to be y1 would be equals to 2 times of A times x plus x1. And in a similar manner, I can also write down the equation of the tangent PR, that would be y2 is equals to 2 times of A plus multiplied with x plus x2, right? Now since h comma k is passing through both the lines, so therefore this both the line would satisfy the coordinate h comma k, right? So therefore if I satisfied h comma k, because I want to find out the x2 y2 and x1 y1, so that I can draw the equation of the chord, right? So my try over here is that since h comma k passes through over here, so the result is going to look like this, right? Okay, so this is how we will have the two more equations, right? Since this tangent P and P at point Q and point R passes to this point P, right? Therefore, it is very clear. So from here, it is very clear that the point Q and point R lies on the line. So from here, I can also draw a conclusion that since it is like just changing the x1 and y1 with some point, so therefore I can say that point R and Q are lying on the line that is given equation as ky is equals to x plus h times of 2a. Okay, this is how the equation lies on, right? Which is very similar that if you again try to write down the t equal to 0 with respect to this point P, this is the same expression. Okay, so therefore this is the equation which is satisfying both Q and R, which is nothing but the equation of the chord of contact. Okay, so this equation what I am getting, since these are passing through point Q, Q and R, it is the chord of contact, right? I hope you have understood this particular step, right? It's a very interesting step. What you can see that since point H and Q satisfy this both this equation tangent at these points, right? So since H comma K is satisfying over here, so this equation looks as if you are just changing y1 and x1 in these two locations, right? So if I have this equation with us, and if I just put x equals to x1 and y1, then I will get the first equation, and if I put x2 y2, then I will get the second equation, right? So these two equations are definitely satisfied by point Q and point R by this equation, right? So what I'm trying to say is this particular equation is satisfying both point Q and R. That means this is the equation of the line passing through point Q and R, and this is a straight line which is passing through point Q and R, and this gives the exact same feeling that it is the equation of t is equal to 0 with respect to this point, P, and that is given as coordinate as h comma k. That's coordinate is given as h comma k. Okay, is this part clear to all of you? Is this part clear? Okay, so this is a very interesting problem or interesting way of discussing a simple problem, right? So this is how we get the chord of contact, right? Which is the similar expression that you have already seen in your chapters of circles, right? Okay, so we have a comment that is Thunder 11U1T. Can I crack JEE in 1 year? Please tell. Yes, you can definitely clear JEE in 1 year. Okay. Yes, surely you can crack JEE. Okay. You just need to have a good preparation or a point of a good motivation also to know that why you are basically clearing this examination. Okay. And also you have a solid plan. You have to have a plan, right? So have a motivation behind why you want to clear this examination. And if you have a plan, please stick to that plan. Okay. Try to first of all finish the high weighted chapter. Okay. And then once you finish the chapters, please prepare the previous year questions. Okay. Previous year questions are very, very important. Is this part clear to all of you? Okay. Now, similar manner, if I also discuss about another concept, that is the chord at a or equation of chord whose midpoint is given as x1 y1. Okay, or chord at a midpoint. Chord at midpoint that is given as x1 y1. Okay, chord at a midpoint. So if I want to discuss about chord at a midpoint or the equation of chord at a midpoint. Okay, equation of a chord at a midpoint x1 y1. What does it mean? That to my given parabola, if I take up 2 points Q and R, Okay, and if I draw a chord, the chord midpoint is given as x1 y1. So I want to try to find out this equation of this chord QR whose midpoint is given as x1 y1, right? So again, since we are discussing a parabola, so let us take the case of parabola. So let us take a simple standard case of parabola, that is y square is equal to 4ax, right? So for this parabola, if QR is a chord whose midpoint is x1 y1, that basically means, let us assume the coordinate of point Q as x2 y2 and R is x3 y3, right? So since these are points lying on the parabola, that means they will satisfy the parabolic equation, right? So that means y2 square is equals to 4a x2 and y3 square would be equals to 4a x3, right? This will be satisfied, right? Now from these two equations, if I subtract these two equation, if I just subtract these two equation, y2 square minus y3 square would be equals to 4a times of x2 minus x3, 4a times of x2 minus x3, right? So therefore from here, if I simplify, that is y2 minus y3, so I am just applying some of the algebraic equation, right? So y2 square minus y3 square can be written as y2 minus y3 into y2 plus y3. So y2 minus y3 divided by x2 minus x3, I'm writing it as is equals to 4a times of y3 plus y1, sorry, y2, right? So y3 plus y2, so by midpoint formula, the value of y2 plus y3 by 2, the value of y2 plus y3 by 2 is equals to y1. So from here we can write this value as equals to 2 times 2a by y1, 2a by y1, right? Now if you recall, this expression is nothing but the expression of slope of the chord r and q, right? So this is the slope of the chord rq, which is going to come out as equals to 2a upon y1, 2a upon y1. So if I try to write down the equation of this chord, that is y minus y1 is equals to 2a times of y1. Now why I am writing always in terms of x1 y1? Because I want to know the equation in terms of x1 y1, because x1 y1 would be given to us, right? So from here I can write down this equation. From the result I can write down this equation, and that will give me the result, that is y y1 minus 2a x plus x1, it would be equals to y1 square minus 4a x1. It would be equals to y1 square minus 4a x1, right? So this is the giving me the same feeling that this is the equation of chord with a midpoint, that is t is equal to s1. Okay, t is equal to s1. So t is equal to s1 would actually help me transform or write down the equation of a chord with a given midpoint whose midpoint is x1 y1. Okay, is this part clear to all of you? Is this discussion clear? Do let me know in the live chat, is this clear or not? Right. So we can take some more problems also. Now with this, we are almost done with our entire chapter. Okay. So maybe I can give you another very simple problem to solve for as a homework problems. Okay. So you can try to solve these kinds of problems. Okay. So let me take a very simple problem. Okay. So here it is mentioned that you have to find out the locus of the midpoint of a normal chord. Okay. Of this kind of parabola. So what is meant by normal chord is that if you draw a normal at any point P and it intersects the another other the curve at any other point Q, right? So if you draw a normal at P and it intersects the parabola again at Q, then that PQ is called as a normal chord, right? And we have already discussed about this question about normal chord, that if I draw a normal at point P whose parameter is T1, then this normal at point P intersects the parabola at point T2 whose value of T2 is given as minus 1 time minus T1 minus of 2 upon T1. Okay, minus T1 minus 2 upon T1, right? So from this relation you can find out the midpoint of this normal chord, right? So the midpoint, if you assume it as h comma k, so h comma k you can find out from this two relation, right? So easily you can do it and you can finally get to this final locus, right? So you will be getting some answer. So the answer to this locus, so the locus which I have got from here, you will be getting something as 2x by a would be equals to 2a by y whole square 2a by y whole square plus a times of, sorry, 2a by y plus y by a whole square. So this is the relation of the locus you will get. Okay, so this would be the final answer. Okay, so please try to solve this out. It is a very simple problem. You have to just find out the locus of the midpoint of the normal chord. Okay, and we have already discussed about these two relation. Okay, so please try to apply these two relation which I have discussed, and from there you can easily solve this problem. Okay, so these are the all the different set of problems that you can try to encounter in your examination. Okay, so I hope with this I was able to help you out with a good discussion of this chapter, right? And I don't think with this we will need require any more kind of preparation, right? So please follow these lectures carefully, and whatever we have studied, please try to discuss and also try to revise those concepts as well, right? And try to also practice some problems, right? And we're definitely going to start with a previous year question discussion very soon, but before that you can also do some of the question practice from your side as well, right? So that is all what I'm trying to end this particular chapter here, right? So with this, in our next class we are going to start with the chapter of ellipse. Okay, so please be ready for ellipse in tomorrow's class. Okay, so from tomorrow we're going to start with ellipse. So this is the point where we're going to start tomorrow in our next class. Okay, and tomorrow we will be discussing about ellipse with the basics of the ellipse, and then we'll again go with the same flow, right? So by now you must have understood that in coordinate geometry the important portions are basically to write down the equation of tangents, normal, and the basic concepts regarding each of the geometrical points, right? So that's all that you need to discuss and understand, especially for your JEE mains examination and JEE advanced examination. Okay, so as per your JEE examination is concerned, these are the all concepts and all the topics that you need to study and understand, right? And apart from this, if you want to study and more, you want to go deep into it, you can definitely go and prove all those results. Okay, but that is up to you. Okay, but for JEE relevance, these are the content that is very relevant for your JEE mains and advanced examination, and these are all things that you need to do over here, right? And also we are going to start very soon with our revision sessions, so please don't forget to stay tuned with our revision session. Okay, because this revision is going to help you up a lot, especially in preparing short notes and also keeping up with the short notes for your actual examination. So definitely, if you take advice from me, I would definitely say that revision with short notes is going to be very beneficial, and it is definitely very helpful, especially for your mains examination. Also for your advance it is also beneficial, but if you think of this JEE mains first attempt, definitely if you revise well, if you prepare from the short notes, then definitely it is going to be very easy and simple. Okay, so with this part I would definitely conclude my session over here, and with this we hope to meet again in our next class. Okay, so thank you for your time and I wish you all the best.